All right, beautiful people, part 3. We are on number 6 of the pre-test number 1. Again, warnings, disclaimer, if I get something wrong, let me know. If you hear a loud bell, I'm sorry. And then we're going to get started. Okay, find the volume of the rectangular prism. This is basing off of your knowledge, your previous knowledge from the previous unit. Rectangular prism, I let you know that to draw a picture, it's just when you see it visually, it's easier for me. You don't have to. So length, width, and height. So length is x, width, again, my picture is not drawn to scale. The objective here is for you to know that the volume is equal to the length times the width times the height. So all you're doing is you're just multiplying these together. So again, x times x plus 3, 2x minus 5. If you don't need a picture and you already know how to do this, don't draw the picture. I don't need to do a box method here because I'm just going to FOIL that x in. I'm going to distribute that x in, So I have x squared plus 3x. And then I have 2x minus 5. Again, if you choose to FOIL this, that's good. If you want to do the box method, that's good too. I'm going to choose to FOIL it this one. That is 2x cubed. This one is minus 5x squared. This one is positive 6x squared. And then negative 15x. Again, the middle terms, you're going to simplify those. So we have 2x cubed plus an x squared minus a 15x. Now, a question here is, should I factor out an x? Because you can factor out an x here. You don't really want to factor anything else because this is the volume. This is what the volume is equal to. If we start factoring things, then we're just going to end up where we came from, which is going to be here. Don't worry about factoring. Your question here is just to multiply this out, and you've multiplied it out, so just leave it. Okay, state if the binomial is a factor of the given polynomial. There are different ways to do this, okay? We're going to do through division. Your choice if you want to do long division or synthetic. Because this is linear and the exponent is 1 and a coefficient of 1, I'm going to choose to do synthetic. If the coefficient of x is a numeric like 2, 3, just any number besides 1, or your exponent is any number besides 1, I would recommend using long division, or you would have to divide everything out by the coefficient, or you can't really do anything without exponent. So if it is linear and the coefficient of 1, just do synthetic. And what we're looking for here is it is a factor if the remainder, I don't even know how to spell that right now, r equals 0, if the remainder is 0. Okay, so let's do that. Remember, for synthetic, you are finding out what your 0 is, which is negative 2. You're writing that here, negative 2. You're using only the coefficients, and make sure you put in placeholders if you need it. So always go 4, 3, 2, 1, 0. No placeholders needed. I have 1, 1, 3, 17, and 14. Bring down your 1. We might run out of space. I might have to bring in another sheet of paper, but we'll see. Negative 2 times 1 is negative 2. We're going to add them inside and multiply outside. This is right here, negative 1. Negative 2 minus 1, negative 2 times negative 1 is just 2. I'm going to add them together. 3 plus 2 is 5. Multiply, that's negative 10. This here is just 7. This right here is negative 14. And add them together, we get 0. So the remainder is in fact 0, so the answer is yes. Yes, it is a factor indeed. Okay. Now, everyone's favorite, factoring. Let's get started. Okay. The first thing we always need to look out for is your GCF. Notice that we have an x, and x in each term. Pull out the GCF. In this case, I'm going to pull out the x. So now I have x squared minus 3x minus 10. So this x, we leave it for right now. We don't forget about it. But I need to factor this further if I can. If I cannot, then I can't. Okay, two numbers that when I add them together give me -3, but when I multiply them give me 10. In this case, it's going to be x minus 5, x plus 2. And again, don't forget that x. And we're not trying to find zeros. We're not doing anything fancy. We're just trying to factor and to the simplest term. So we have x, x, x. Remember to always check. If the exponent is 1, you're done. If the exponent is not 1, you must ask yourself if you can factor further. Okay, let's move on to number 9. Number 9, 64 is a number that you should throw glitter on. Remember those numbers. We have 1, 2, 4, 16 that you should throw glitter on. 9 is one of those numbers. 64 is one of those numbers. So make sure that you throw some glitter on that so you are aware that 64 can be rewritten as 4 cubed. Because you can rewrite it as 4 cubed, you have the difference of 2 cubes. So you need to, there's no other way, but you have to just memorize this formula. And that is AB, A squared, AB, B squared. Now I do this for a reason that I don't put in signs here because the signs depend on if you have a positive or a negative between your two cubes. Excuse me. So let's see. If this is minus, it's going to be always same, always different, always positive. I'm going to repeat that. Always same, always different, always positive. So these signs matter when we look at what is in here. This is a plus. These signs would change. Okay. Now our A is our X. Our B is our 4. So we have X minus 4, X squared plus 4 times X is 4X. 4 squared is 16. Please do not write 4 squared. You know what 4 squared is. This is linear, so this one's done. Now here's the trick. Anytime you have a cubic, a difference of 2 cubes, this right here will always be just done. You won't be able to factor this further. So this is your answer to number 9. All right, let's move on to number 10. Number 10, I have 4 terms. And so 4 terms, we can see if grouping works. Fingers crossed grouping works. There is no GCF for me to pull out. I have an X, 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 but no X here. I can't pull out a 2. This one's not. Can't pull out a 2. This is just a 1. So the only thing that we can do here is just see if grouping works. If it does, yay. If it doesn't, we call it prime. Okay. So grouping, I'm going to take these 2 and these 2 together. Here I can pull out an X squared. That gives me an X minus 3. This one here, I'm going to pull out a -2. That leaves me an X minus 3. I am very happy because these are the same. Because these are the same, I'm going to write it once. The next thing is this one here. These 2 in the bubbles, we write together. Okay, now we have to check. Remember, is this linear? Is the exponent 1? Yes, so this one's done. Is the exponent 1 here? No, the exponent is 2, so we have to double check if it factors further. Now this one here, is 2 a perfect square? No. The only way that this would be factorable further is if 2 is a perfect square and we have the difference of 2 squares. 2 is not a perfect square. We are not trying to find zeros. This is all we have to do is factor, so we are done.